Good morning, ladies and gentlemen. Thank you very much for kind introduction, Nishikawa-san. It's a great pleasure to be able to speak to you at such a distinguished institution. My name is Eiji Wakiwaka, working for the Clinton Foundation in the area of climate change, trying to do something about global warming. Climate change is happening on the global scale. But it appears these days that people are not really interested in talking about it. But think of the planet as your human body. To stay healthy, you do a lot of things to prevent future illness, such as exercise or non-smoking, eating healthy foods, or drink less, or some people drink more. Because you know intuitively it's the right thing to do, to treat it before you get sick. A, because it's less expensive, and B, it's less painful. Can we apply the same logic to this planetary system? I know it's difficult to invest money when cause and effect is not 100% clear. But is it very different from your human body that you do? Today, I want to explore with you what we can do to prevent the planetary system from future disaster. Over the next 25 minutes or so, I want to go through the following agenda. First, I want to demonstrate what is happening around the world on climate change with some statistics. Secondly, I'd like to go through some of the choices we have. Thirdly, in fighting against climate change, I'd like to introduce some of the things we are doing at Clinton Climate Initiative and give you some thought about what we can do. And lastly, I'd like to ask you to consider what you can do to mitigate the impact of climate change. First of all, let's set the context together. I understand that 2010 was the hottest year in the recent history. And as pointed out before, our political and economic landscape is rapidly changing. The impact of the global financial crisis. In Europe, this is the biggest subject at this moment. Fukushima, everyone remembers, 11th March, of disastrous earthquake, tsunami, followed by nuclear disaster. In the US, interesting development of unconventional gas out of shale gas or CBM, which seems to provide an alternative to coal power generation. On the contrary, Deepwater Horizon, which was to do with my previous company, is a good example of oil becoming harder to find with increasing safety risk. The Arab Spring in 2011 is a stark reminder of how political stability is essential to stable supply of oil and gas, probably helped by net generation. Finally, 2012 will be an important year for many countries like US or China or South Korea or Russia. It's an election year. So in this context, I'm afraid to say that climate change is becoming a lower priority as opposed to the last couple of years. Let's look at the reality of world temperature. This is IPCC chart, probably you're very familiar with. We know that since the Industrial Revolution, we've been burning fossil fuel. And temperature has gone up to 14.3 degrees on average, up 0.74 degrees. But according to the latest statistics which I heard, the temperature has gone up already 1.4 degrees. This sounds like a minute increase, but in terms of trying to limit the increase to 2 degrees centigrade, which is a blue line, I'm afraid that we will not be able to contain the increase to 2 degrees, but more like 4 or 5 degrees. Every day, we hear the bad news about natural disaster, flooding in Thailand, no fresh water in Africa, heat waves in Moscow, and I heard about tornado in Massachusetts. Not sure if it is all due to climate change or not, but certainly this planet is getting more volatile than ever. Let's look at energy consumption picture, which is a major cause of greenhouse gas. This is the BP statistics in 2011, which for the first time made forecast to 2030 on energy outlook. This is a chart showing global energy consumption growth to 2030, which is business as usual case. Global energy consumption growth averages 1.7% a year from 2010 to 2030. Non-OECD energy consumption is 68% higher, as you can see, by 2030, averaging 2.6% growth from 2010, and account for 93% of global energy growth, which is majority. OECD energy consumption in 2030 is just 6% higher than today, with growth averaging 0.3% to 2030. And in fact, from 2020, OECD energy consumption per capita is on a decline, minus 0.2%. The fuel mix changes relatively slowly. The fastest growing fuels are renewables, including biofuels, which are expected to grow at 8.2% in 2010 to 2030. Among fossil fuel, gas grows fastest, 2.1%, at the expense of coal and oil. Let's look at the impact in terms of CO2 emission as a result of that analysis. First of all, as I said, energy consumption is expected to grow at 1.7%. Non-OECD emission grows by 2.2% on average, up 53% by 2030. Policies in non-OECD countries focus on reducing the carbon intensity of economic growth. On the side of OECD, the implementation of carbon abatement policies reduces the level of emission in 2030, but only by 10% relative to the current level. Overall, this implies some progress toward climate change goals, but not enough to put the word on the path to stabilize at 450 ppm or 2 centigrade degree target set in Copenhagen in 2009. That calls for some policy intervention. So that's the reality, and let's think about solution, how to solve the problem. This is the famous 3 E's for energy supply, I'm sure you're familiar with. Energy economics, environmental impact, and energy security when it comes to energy supply. Energy economics is most fundamental, as you know. Most of the economies seek low-cost energy to stay internationally competitive. Environmental impact is now understood, and many OECD countries and some non-OECD countries are working on decarbonization of the economy. Energy security is often forgotten, where there is ample domestic energy supply, but if a country lacks natural resource, then this is becoming a huge political issue. So this is like solving a very difficult three-dimensional equation, probably easy at the MIT, and there's no one single solution for the best energy mix. Let's look at this table. I looked at 3 E's against 3 energy supply: hydrocarbon, renewables, and nuclear. We know that hydrocarbon will be hydrocarbon has been and will be a future major source of energy for some time to come. because it's easy to use and it's readily available. But longer term, hydrocarbon will be more costly, and we know it's not good for the environment unless you do a CCS, carbon capture and storage, which I'm working on in Europe. And it's probably not good for energy security in the long term because the resource is limited. Renewables. We all like it. It's good for the environment, good for the securities, but perhaps not for the energy economics. It's not good at this moment, given the current technological development. Materiality is an issue as well. Nuclear is somewhat controversial after Fukushima. It was thought to be good on energy economics or environment, but there is a strong question mark and needs further technological development to be safe and reliable. Hence, it is a very delicate balancing act to find the best energy economics, best energy mix. Since we talked about Fukushima, I just want to look at the Japanese case, which I borrowed from METI. This is the latest estimate of power generation cost, which is one of the 3 E's. And it seems that PV solar is highest at today's technology. I'm sure this can be disputed. Obviously, the cost curve is coming down sharply, and I'm sure with the help of a school like MIT, it will come down to become competitive in the near future. On the other hand, nuclear, to take example, only included the running costs under normal operations. But if you include some safety measures after Fukushima and any subsidy to local government and reparation cost of spent fuel, then this cost seemingly is going to go up.